Hi, and welcome back to the third video for the certification exam rapid training for AZ204, the developer focused exam. So what we're going to look at now is developing for Azure storage. So again, this is about 10 to 15% of the exam. We're really focused in on just two areas, which is nice. The developing solutions that use Cosmos DB storage, and then developing solutions that use blob storage. So Azure storage, from a developer perspective, we're focused in on these two areas. So starting out, we're going to look at Cosmos DB storage. And Cosmos, the understanding around Cosmos, these are the various topics that you may see on the exam. So we need to understand the various APIs inside of Cosmos, partitioning, data, interactions with the different SDKs and knowing that there are different SDKs, understanding consistency levels, and there are multiple consistency levels, creating containers. So we need to understand the various structures inside of Cosmos DB, implementing scaling and partitions and containers as well, and then implementing server-side programming, including stored procedures, triggers, and change feed. So really focus in on the change feed notifications and that capability. But really quick, Cosmos DB, all the different APIs. So we're looking at different data structures in the different APIs that we can access and use for Cosmos DB. We have SQL, MongoDB, Table API, etcd, Gremlin, et cetera, et cetera. So these are the various APIs. The various data structures include key value, column family, document, and graph. So those at the very bottom are the features essentially, but this is selecting the appropriate API. We need to understand the different APIs and the different structures associated with each of these varying APIs. Consistency models. There are 5 different consistency levels, from strong all the way to eventual. So what we want to really understand here is how they impact availability, latency, and throughput for a particular application workload. So I highly suggest you go read the consistency levels doc on Microsoft Docs, and I've got a link in the presentation. But understand consistency levels at a high level, what they're going to impact in terms of availability, latency, and throughput. So here's a quick description of those consistency levels, direct from the documentation. Again, they range from very strong consistency where reads are guaranteed to be visible across replicas before a write is fully committed across all those replicas, to eventual consistency, where writes are readable immediately and replicas are eventually consistent with the primary. So understand the differences there and how that impacts your applications. So again, we're going to deep dive into the various APIs. So we want to understand the various APIs. I go into that here with all the different APIs and the differences in terms of their data storage and capabilities. So understand the structures is really what we're looking at, and understand their usage. So again, here's more of those APIs. And again, focus in on the various structures and understand that we've got SDKs and access to all of these various APIs. So from a resource hierarchy perspective, we really want to understand the JSON document stored in Cosmos DB. They're managed through a well-defined hierarchy of database resources. So the hierarchical resource model, we really need to understand this in terms of the exam and what these various pieces are. So again, this kind of goes into the resource hierarchy and some of the various terms that you're going to be looking at inside of Cosmos DB. At a high level with partitioning, if you already understand the sharding pattern of past databases, the idea of a dynamic partitioning, it's not really different. And then you're going to also look at physical partitioning. So do understand partitioning and how it pertains to containers. And again, containers are the logical resources. They can span one or more physical partitions or servers. So that's really where we're keyed in on. and understanding the partition and how it impacts your application, your particular workload. So furthering partitioning, a logical partition is a partition with the physical partition that stores all the data associated with a single partition key value. So the partition ranges can grow, can be dynamically subdivided to seamlessly grow the database as the application grows while simultaneously maintaining high availability. So when a container meets the partitioning prerequisites, partitioning is completely transparent to the application. So you really need to understand that key aspect. Moving on to blob storage. These are the various topics in terms of blob storage. The key is understanding the usage of blobs and how to interact with the data inside of a blob and a blob resource hierarchy. What types of data are you going to store inside of a blob? That's really the key here, and why we're going to use blob storage and how we interact with blob storage. So understanding blob storage is for object storage solution for the cloud. It's optimized for storing massive amounts of unstructured data. So we're looking at unstructured data that does not adhere to a particular data model or definition. So we don't have any particular hierarchy. Examples can include text or binary data. A lot of times blob is used for images, media, and some of those other types of binary data. Users or client applications can access the objects in the blob storage using HTTPS, so secure, from anywhere in the world. Objects in the blob storage are accessible through the Azure Storage REST API, PowerShell, CLI, your standard interfaces, as well as an Azure Storage client library. So there's client libraries that are available across a variety of languages, including .NET, Java, Node, Python, Go, PHP, and Ruby. So know that you can access it through a REST API, and it's across various languages. So understand the Azure Blob storage resource hierarchy. We really need to start with and understand a storage account, its association with a container, all the way down to the particular blob. So you can see here, we're storing media. We may have containers for both images and videos, and then the actual blob contains the binary file itself. So it's understanding that hierarchy and how you access the various components in that hierarchy. So Azure Storage also offers different storage tiers, all the way from premium to archive. So understanding the different usages of these tiers and that you can move between the tiers. And why would I move between the tiers? Again, this may be due to the fact that I'm trying to save costs, or I need low latency in terms of my application workload. I really need high IOPS so I can access my particular piece of data quite quickly. I'd use premium for that. If I'm not too concerned with access and I want to use cheap storage and I just want to store it out there for a long time, think of tapes back in the day, essentially writing to tape. Pulling that data out is going to take quite a while. So retrieving that tape, that'd be archive storage. And do understand you can move, again, between these different tiers, and you could do so with an API or through the portal. Speaking of moving through tiers, you need to understand lifecycle management. This is a way to essentially move through those tiers, and it's a rule-based automation. So think of data that hasn't been accessed in 60 days. We want to move that to cool storage, for instance. That would be a rule that we could actually apply to the storage account through a policy. So the policies let you transition, again, to those different tiers, delete maybe a blob at the end of its life cycle, maybe apply a rule to a container or a subset of blobs by using prefixes as filters. So you could do a lot with rules, and you can actually have multiple rules and nested rules. So here's an example of the various rules inside of a policy. So you can have up to 100 different rules in a policy with a rule name, the rule definition can be made up of the filter set and an action set. So understanding the policy layout and how you apply the policies is key to lifecycle management. And this concludes the third video, and we're going to focus in on Azure security for our next video. Thank you.